So we are back again after refreshment. Now,
I would like to introduce our guest, Dr. Namarup Acharya, who is Associate Director in JIS, Kolkata, Director of Record. He completed his PhD in Electronics and Telecommunication from JIS University. He will enlighten us on convergence of IoT and AI to develop smart cities.
right. I would like to request Julie ma'am to illustrate our session. So after a wonderful session of IoT by Dr. Devasitya sir, now Varun sir will teach us about IoT with AI and develop smart cases.
Sir,
So, good afternoon, everybody. I understand this FDP is all about smart systems and industry 4.0, etc. So, in tune of the theme of the FDP, I will try to take you through the stories how IoT and AI can be converged to develop smart systems. And as an example, as a use case of the smart system, I will try to tell you the story how we could develop an electronic olfaction or electronic nose system using or leveraging the various emerging technologies and how converging them together to design a system. So before that, you all know that there is a very fast changes happening in the emerging frontiers of technology. And this kind of technology starting with nanotechnology, then communication technologies, Internet of Things, artificial intelligence, machine learning, robotics, big data, virtual reality, augmented reality, RFID, blockchain, etc. They are actually taking all, they are coming inside all the applications. So, what I have tried here, that how all these technologies, as it is there, but they cannot really come to life unless they come to some real use cases. So I try to take you through how these technologies can be really leveraged to develop electronic nose. So before that, the technologies, emerging technology, big heads that I have tried to tell you. One of them is nanotechnology, so not to take these slides very seriously, but to remember only that nanotechnology is the heart and soul of all the devices that we are using these days in high performance computing, in embedded systems, or in any other real time or any other IT-based application. So this is very, very important. And intense research is ongoing all over the globe to really develop newer things in this front. Then another technology which is really making a lot of changes in the previous presentation, Devashish was telling, the drone technology, etc., 6G, 7G, 8G, 5G, because 5G is already really for all of us, where you can have multiple connected devices in a much faster rate they can communicate. So days are going to come, all of us individually will have 2 to 3, I have got one phone with me, I have got one smartwatch with me. So people will be having a lot of wearable devices. And the entire the social sector, administrative sector, governance sector, health sector, the urban living sector, agriculture sector, environment sector, all are going to be full with connected devices. And these are the technologies. Then only will take you to the real implementation of solutions that will be good for societal this thing. So 5G, 6G, 7G, all about speed, all about more bandwidth, faster, higher data rates. Even you can go, you can sit in the airplane and have your telephone calls. So those kind of things are going to unfold. And IoT, all of you know what it is, Internet of Things, because many of you are students of computer science or electronics. So please remember, Internet of Things, IoT, has to have essentially either in the front end or at the back end, either a sensor or an actuator. It's a must. IoT doesn't have any meaning unless they are either front-ended by a sensor and terminated with the actuator. Either of them has to be there, any IoT. Then only that sensor along with communication becomes this IoT system. The communication thing is added. Tomorrow, if this chair, if we has a sensor which monitors temperature, which monitors the relative humidity, which monitors the pressure or weight of the person sitting, so this is also IoT enabled, because then you can communicate that information over any media to some remote device or remote applications. So IoT, please remember. Then another thing, artificial intelligence, this is a jargon. I have a book in my home, 1975, titled Artificial Intelligence. So this was there. But since, please remember, since nanotechnology was not developed, since communication technology was not developed, since computing didn't have adequate power, since memory technology was not that strong, we really could not bring artificial intelligence to real applications. So now, since other things are strong, this concept of artificial intelligence has been there for long. But now, AI-based applications, even up to the generative AI or transformer model that you are getting today, is coming to life because you have got high performance computing, because you have got high rate of communication, because you have faster devices, because you have higher capacity of the memory. And all these technologies are actually enabling the very old concept of artificial intelligence, which is empowered with a very strong tool called machine learning. Actually, it's an integral part of artificial intelligence. If machine learning is not there, artificial intelligence cannot be implemented. And if artificial intelligence is not there, there is no use of machine learning. Just like human beings, we should have our neurons to transmit, our brain has to compute, and our memory has to retain. So machine learning is related to how we learn, and our intelligence also, they are actually integral part of each other. Just remember this. I just telling this. And another very big frontier is being opened. That is robotics. The drone, that the previous thing, that's also a robot. That's a flying robot. That's a flying robot only. And what robotics does just any movement, maybe humanoids, maybe any machine, a lot of defense devices these days in an atomic energy or in a nuclear energy ecosystem. Human beings cannot go due to radiation. For years, robots are there in those places to really handle some materials which are highly radioactive. No human being can go there. And that has been the pick and place mechanism robotic manipulators. They are very much there. Now they have become really stronger. Once again, because of development of sensing technology, IoT technology, communication technology, high-speed computing, onboard computers with GPUs, GPU onboard GPUs. So this technology also is taking us to new paradigms in various use cases. Robotic surgeries are there. Precision agriculture using robotics is there. Automatic spraying machines. In the agriculture domain, environment domain, everywhere, this is making a lot of things. Of course, once all these technologies, communication, devices, connected devices, computing is so strong, then you have a lot of data and real data, sometimes unstructured, and then only this new technique called big data analytics and all have really started making foray into our things. And this kind of big data, when data becomes really big, then you really store it on cloud, because nobody wants to have individual machines, servers, and memories here. So there will be remote cloud. So big data on cloud. Please remember, whenever you are dealing with big data, it has to be on cloud. Nobody these days wants to have the really tantrums of keeping all the infrastructure. Then, as such things have become very strong, the very natural fallout has been the presentation technologies, visualization technologies. So, augmented reality and virtual reality have come. You have seen those 3D glasses. You have a 3D glass and you can have a simulator, flight simulators, automobile simulator, lot of training. These days, augmented reality is used to train doctors how to do a surgery. Because otherwise there is no way a doctor can learn how to do a heart surgery, except opening a dead body and going into the heart in the real life. But now, this augmented reality, they are actually having feel of the surgery. And this kind of stuff is making, and they are high footprint software programs. They need a lot of memory, they need a lot of computing, they need a lot of high speed communication. So that is already under development and has developed to a great extent. Then of course, radio frequency, RFID, this is not high tech, but this is there on every, see, once you have big data, you need identification of data also in the real use cases. So RFID technology, I just thought I will mention, this is one of the tags that is really helping these smart systems, how it can be developed. Then blockchain, this Devashish was telling, blockchain is block, chain of blocks. Chain of blocks. What the blocks contain? They contain data, some data, and these data, previous block's hash function is added to next block. Then previous block hash function is added to next block. So it's immutable. If I change any block, any data, then the next data also gets disturbed. So you can't really change anything. That's why, as of date, this is the most secure technology in terms of keeping your data, and it's being extensively used in a number of applications in all the states of the country. The biggest dispute in the villages is the land data. See, farmers always will have a problem that this is my land and this is your land, and whoever is stronger in socially or politically or economically, they will try to grab the land of others. So this land records in blockchain has started making very big success, so that no disputes, nobody can grab, I cannot grab her land. So this kind of blockchain technology is very important, and coming into many applications. So what I try to tell you that this workshop is about smart system, smart cities, industry 4.0. They need emerging technologies to be really harnessed to produce some solution for the particular user or the society or a particular domain. Now, these things are the major technology revolutions. In addition, sector-wise, domain-wise, huge development is going on. But how these technologies can really be leveraged to develop a system, I will share my experience with you. How we could develop electronic sensing system for smells, how to sense smells. And we develop using this technology. In the future slides, I will share our story of how things were developed. Okay? Oh, this one more technology is high performance computing. That also you must remember that everything together, supercomputers are in place now. As I was working in CDAC previous to MacOut, and CDAC makes the highest, is the most fastest supercomputer of the country, and there is a national supercomputing mission on where all institutes in the country also this supercomputer are going to be installed in days to come, and they have now they are going to exascale computing, from data to exascale computing things are going. Now I will share you the story of development of electronic nose for tea quality assessment. That was the story I chose to share with you. Now, first of all, come out of those technology field. Now we drink all tea, and most of us have gone to either Assam or North Bengal or South India, the Kunu, Uti, in these areas, and we have seen tea gardens. Have you seen or not?
Yes. Yes.
All of us have seen when train passes by and car passes by, lot of tea gardens are there. Please know, tea is one of the most important cash crops for the country. And more than 20 million people in our country have their livelihood on tea. It's a huge cash crop, and we do a lot of exports. In addition to, we have a lot of internal markets. Now, how tea is processed? First, leaf is plucked. Then there are a series of, there is a field and there is a factory. Now, in the factory, they go through, I will not go to these processes with the reconditioning, etc. But basically, the green leaves are cut and macerated. They call maceration, process of maceration, and then the black tea that comes. You can say finally, this there's a black tea that actually we get to buy in the market. And please know, this tea quality mostly depends on the quality of leaves. The grown of that particular leaf, that's the major determining factor. And during processing, you cannot improve the quality. You can spoil the quality by wrong processing. But if intrinsically tea quality is bad, if the leaf quality is bad, you cannot make a better. Now, when this tea is tested, they are tested on 4 basic parameters. Color, how black or little brown color of the tea is. Then flavor. Flavor is actually a combination of taste and smell. Not only taste, not only smell. It is taste and smell. If something, you would suppose some bitter medicine you want to eat. You put the medicine and put the flavor. You will not get a taste. Because flavor component you have killed. That's why it goes smoothly. So, flavor is very important. It is combination of taste and smell. Aroma is the only smell part, that is the intrinsic smell of any compound is the aroma, and strength is, we say na, the karak chai, how astringent, how strong the tea is, that is strength. These are the four major parameters based on which tea is evaluated or assessed. And please know, taste of not only tea but also any fluid comes from non-volatiles. See, volatile means the compounds that come out in the air in the normal temperature. And non-volatiles is they remain in the solid state or liquid state. They don't come in the vaporized state. So, any taste of any fluid is determined by the non-volatile compounds within that. And smell or aroma is by the volatiles, the compounds that come out in the air. So this is what is the thing. Now, for tea testing, like once we went to the tea industry to try to find out how it is done by tea testers. The so-called tea testers, they are very costly people, and they are supposed to have ultra-sensitive palate so that they can differentiate and classify various teas. Unfortunately, my experience we have seen that very renowned tea testers also, morning they grade the same tea something, evening they grade something. Because human variation will be subjective. Human assessment always will be subjective. There is no denying this fact. And tea tester to tea tester, there is huge variation of the things. And so this is one way of testing they do as of date also many cases. And there are some instrumental testing which are really chemical laboratory test. You have to add a number of reagents, then you have to have expert manpower, then gas chromatograph, HPLC machines you have to sit, and then you can find out which compounds are there in tea. So these are the two methods which were available. So this is how this sensory panel, that is the tea testers, they do. They take a big bowl, they brew the tea, then they are made in a place where this type of liquors, color, etc. they see, taste they see, and then they see. And that's how they do the entire testing. And for the instrumental testing, as I told, a lot of tea extract has to be made, a lot of reagents have to be added, etc. And you need expert manpower. And both the methods, as of when we went here, they were actually not repeatable and reproducible. The main problem of any system developed, it should be repeatable, means same thing, same things you test in a number of times, it should give the same result. Reproducible, same thing tested by different operators, it should be giving the same result. It doesn't really fit into repeatability and reproducibility aspect of any system. Then, so there was a need for some rapid testing, so that in a non-invasive way, you quickly should be able to know or quantify the quality of tea. And for that, we started exploring the electronic dose options. And the electronic dose options, when we started exploring, we find that actually human has got 5 senses, 5 perceptions. And you see that eye, actually camera is an electronic eye. All cameras, actually they can capture image, they can analyze image, they can process image. So just like electronic eye. Then microphone is an electronic ear. When I am talking in a microphone, actually it captures my audio, it can process, it can amplify, it can filter, it can do all kinds of stuff. Similarly, touch sensitive devices are there, all our mobile phones or everywhere you have got touch sensors to some extent implemented. But the smell and taste, these 2 senses, actually electronic mimicking through sensors, that is not very popular or commercially available solutions are there as of date. As of date, lot of experiments are going on, lot of research is going on all over the world. So this attracted us, can we make an electronic nose to mimic the sense of smell so that that can be reversed to quantify the quality of it. So electronic nose actually, our concept was that it senses a complex odor. Now, suppose this flower is kept here, and if this is a fragrant flower, so volatile compounds will be available in the air around this flower, and then when we inhale, so with the carrier air, those volatile compounds will reach our olfactory senses. We have got sensors in our nose, so that will go there, and those sensors will have chemical or biochemical reactions, and then that output will go through neuronal pathway to our brain, and we will say, yes, this is a good odor, or this is a wrong odor, this is a pungent odor, this is an obnoxious odor. So basically, the way human being smells, if you want to try to make an electronic nose, it has to be like the human being, so that it really mimics the sense of smell. So what happens, this odor stimulus should have a pattern in our brain. It goes as a pattern, and our brain recognizes that pattern, and the smell print can be classified in the electronic nose. I'll tell you this thing. So this is the basic block diagram of electronic nose. What I told, this has to be a sensor array. Array means combination, not one sensor. It's a multiple sensor array. Then if there is one sensor or a number of sensors, there has to be signal conditioning electronics. Then data has to be acquired, because whatever sensor sense, any sensor in this world, the output will be analog. Because sensor senses from the nature, and nature is analog. Nature is not digital. So once you sense anything, it has to be conditioned and converted in the form of a data that a computer understands. Because computer understands data, and data acquisition has to be done in a computer. So sensor to data has to be there in any IoT system. Okay? And that data now is, you are free. You have got now developed tools, machine learning, AI, etc., blockchain, whatnot. Everything you have. So you can analyze, you can cluster, you can classify, you can correlate, you can quantify, and whatnot. So, but one block I draw your attention to, that is odor delivery system. That is an integral part of electronics. So before sensor, like I told you, when we inhale, through carrier air, the molecules are taken up to our sensor. Here also, the smell molecules have to be driven onto the sensor head by some extra module. So electronic nose should essentially have an odor delivery. Then these are the kinds of sensors already available. There was metal oxide semiconductor sensors in Amazon, you can buy, and they have a characteristics that when some volatile molecules come onto its surface, this resistance changes. Resistance changes. Everybody understand resistance? And if I get something, some response in terms of change in resistance, so for me to convert into a signal is very easy. I can convert it. So exactly that is done here. So metal oxide sensor, when the molecules, odor molecules go onto the surface, the phenomenon of adsorption takes place. Adsorption. Adsorption is not absorption. Adsorption is loosely coupled. Loosely coupled. And they exchange some electrons here and there, and that's why the change in resistance takes place. And these kind of sensors are good for electronic nose, and we have used this kind of sensors in development. And these sensors I have given, actually when you go to buy sensors, you will get that some numbers like this is part number, and this is sensitive to propane and butane. The other thing is sensitive to methane, etc. Something will be sulfur dioxide, something hydrogen sulfide, something carbon monoxide, this kind of things. But when a complex odor is there, odor molecules are not there, those things. So there lies the challenge. You have to optimize a sensor array which will be sensitive to the targeted volatile organic compounds that are coming out of your tea or if anything else in there. So what we did, we first went to what are the major aroma determinants of tea in close consultation with the tea biochemistry experts, tea experts, etc. And you know, everything has got a chain. Every molecule, say I am not chemical chemistry expert, but the way I understood the absorption is this chemical will have chain like this, something will be chain like this, something will be chain like this, and all will be flying in the air. And when you root them on the surface, then the interstitial gap of the surface, those things only will sit, which fits wherever. And if you have an array, butane one will have some length, ethane one will some other length, so whichever is suitable, they will just sit and make a pattern. And what we have done, after studying this major aroma determinants, we did a huge study with various sensors. And we saw which sensors respond best. And then with them, we have made an array where with 8 sensors, a good sensor response and repeatable and reproducible response in tea we could find. And then this is the sensor array that we finalized. So I am once again telling you that sensor selection and optimization is a big, we have got a number of papers on this. And once you optimize for a particular application, then these 8 sensors will create a pattern for a particular smell, and that you can classify that using your machine learning techniques. So this is the interface circuit. This is the signal conditioning. We used simply data acquisition boards, that is USB compatible boards of lab national instruments. These are the data acquisition boards. And signal pre-processing, we did some signal pre-processing like baseline identification and manipulation. There's any signal processing should start with pre-processing and data compression. And then baseline handling has been done in this way. I will not go into details. Compression we have done. And these are the characteristic response of various sensors. This is time, and these are the various the way the sensors respond. And odor handling and delivery system had a pump, and this is how air is blown and then it is taken up to the sensor. And we did a heating also by illumination based heating for the listing, so that more these volatile compounds are released. Then a typical sniffing cycle, actually what happens, first heating, then headspace generation for blowing air, then sampling, then the sucking, and then purging. Once it is done, once sampling is done, then you blow fresh air, clean the sensor head, that's called purging, and then keep it to dormancy for some time. So this is the typical sniffing cycle of an electronic nose. So this is the first prototype nose that was developed. Later it had got a lot of this thing. I'll just show you how the electronic nose works.
day 6 session. Session 1.
See now, now you play that. You see, this is how electronic nose works. See, first ambient air is pumped. This is the sample holder, and this is how this is sensor array, and then entire processing is done. Data processing is done on a computer, and you can get a t-tester like this. So basically, what I want to highlight here, so we have seen internal operation of electronic process. Here I just want to tell you that from sensor to data acquisition to the computer, this is actually IoT. And this can be wired, wireless also. In a remote place, you can have this. And instead of a odor sensor, there can be a different kind of sensor also. There can be electrochemical sensor. There can be a piezoelectric sensor. So that you can have, suppose a machine vibration you want to have, you can have a piezoelectric crystal. And then after that, the entire thing is machine learning AI. Because what we have done, we have trained the system with a huge amount of t-testers data, annotated with t-tester scores, and thereafter any unknown sample given here, it gives t-tester score with 95% plus accuracy. I just quickly now show you, this is the olfaction software. It is a PC supported system. Now it's embedded version also is there. Then these are the various modules of the software, and the data analysis basically, this is the data and this is the sensor responses when exposed to P odor, and this is the headspace baseline things. And we have quantified data analysis strategy has been exploration, quantification and correlation. This way, first exploratory data analysis using clustering techniques, then you go for this data quantity. We have found some index of P quality, we have given some index of P quality and data correlation with the t-tester scores with the instrumental analysis, that also has been done. And these are various results. I will not bore you with all these things. See, we need a data correlation using this neural network also, but the 8 sensor nodes, but the 8 inputs and internal hidden layers that this thing is out. On the output side, we have 0 to 8 scores, t-tester scores. So that kind of things we have successfully experimented. And details of experiments, there are a lot of data analysis efforts were done. And we can analyze techniques. Fermentation. So this, what we can see, that accuracy of detection of fermentation completion time by T3, there is a process called fermentation. Accuracy we are at 95%, and accuracy of detection of fermentation completion by kilos vis-a-vis human evaluation is 96%. And these are the various experimental. This is the final shape of our electronic nose and vision system together that was commercialized. That is now commercially available to companies. They market it in the industries, and we have added electronic vision and electronic tongue also to the entire system, but today I will not discuss those things. Now we have had a handheld version, that is the embedded version of the electronic nose system that is used for the flower quality evaluation. Jasmine is one of the major cash crops in South India, and the jasmine extract is called concrete, and that is exported to France for all this perfume industry. But there is no methodology how they can quantify the quality. Actually, those manufacturers, they used to send the concrete to France, and whatever price they are paying, they are accepting. But they are now using our electronic nose to quantify the quality of their floral extracts. And a number of products we have developed based on this kind of electronic sensing technology, and all are smart products. I will not go into, this is our floriculture, ENOS for floriculture I showed. Then ENOS for aromatic rice, our system is now commercial. That is, a lot of rice is sold, long grain rice as basmati rice. And these days, they add a lot of adulterant also. And those smell don't stay more than 3 months. So that can be classified using our machine, where the exact smell is captured of the aromatic rice. Then in FCI godowns, our systems are there where fumigation monitoring. What happens? Has anybody gone to any FCI godown, Food Corporation of India? So there what happens, huge stacks of these food grains and pulses are there. Now, to save them from rotting, because there are a lot of insects out there, very small insects. So they have to light phosphine gas. Phosphine is actually a poison. And phosphine gas, and that process is called fumigation. And what happens, this phosphine effect once goes low, definitely all insects come there, and they spoil, and that smell starts coming all over. So this fumigation monitoring, our system is extensively used in Bombay, very big FCI godowns in Raipur, in Calcutta. This system is also commercialized and using same electronic nose technique. They look for a specific gas and then find out what exactly is the situation. Then we have done a project in Bhopal where the storage house of potato and onion, and as soon as rotting starts, the smell starts coming. And we immediately clear that side of the storage first. So this is also commercial. Then biosensing system also, see, instead of sensors, in metal oxide sensor, you can use biological sensors also. Have a better sensitivity, better selectivity. So for pesticide residue detection in fruits and vegetables, we have used it. Robotics in agriculture, I just wanted to take you through that. These sensing technologies, a robot with a smelling capability, also we have started working in so that it goes across the field and tries to find out any bad smell. So conclusions will be yours, of course, but I'll try to urge you to think that sensor devices are outcome of nanotech research. I told you nanotech is the driving force of the big technologies. Sensor and a front-end leverages IoT techniques. So IoT, nanotech, they are used. Self-learning methodology employed leverages AI/ML technique, that is self-learning by the electronic nose, the tester, smarts, etc. AI/ML. Then advanced communication techniques, blockchain technology, etc. may be employed in numerous ENOS applications. See, ENOS data can be really taken to through communication channels to many places, or many use cases can come up. And ENOS may be a direct catalyst in robotic applications, in smell-enabled robots. That also can come. So, how IoT, nanotech, AI/ML advanced communication and advanced robotic things can converge together to make a smart system. That's what I wanted to just highlight to all of you. And this is just an example, electronic goods. Any application, like Industry 4.0. See, what is Industry 4.0 all about is intelligence in the automation. See, conventional automation had been there, high-end automation, but intelligence was not there. So Industry 4.0 will usher in intelligence, where a product and a process will talk to each other. So that kind of things can be done with all these technologies. Thank you for খুব বেশি সময় দিইনি ঠিকই তো আছে হ্যাঁ খাওয়ার আগে আটকে রাখাটা খুব বাজে। যাবে তো?
What a wonderful session it was. First time I have heard a nose, and AI has also connected with it. Robots have a nose, and they will show safe as well. So after the introduction, I will actually request Judy ma'am to felicitate us at the moment. Ma'am, please. Now, as we flew too much ready today, so there's a break, lunch break, and after the lunch, we'll continue our lesson again. So,